Tell me what the title of section 3.4 is. Adjacent angles and what? Linear, or really linear pairs. But I like that you said linear. That has a little something to do with, yes. So since we're talking about that, let's start. Well, we got to start with adjacent. Never mind. We got to start with adjacent. Yeah, adjacent. The word adjacent. What does it mean in the really real world? Next to or beside? I like yours better, but I was already writing that. Next to or beside. Okay, that's what adjacent means. Well, I am going to draw three types of angles here that seem to be beside each other. I'm going to each of the two angles, angle 1 and angle 2. I don't want you too worried about drawing this as much as paying attention. Okay, so I'll say which angle 1 and angle 2 are adjacent angles. Yes, which one do you think? He's a man. He is right. This is the only one of all of these. And for a second, stop writing so you can listen to the explanation here. That are adjacent. Can anyone tell me why this one is not adjacent? I'm hoping you kind of read ahead and read the definition. They're kind of not connected. The thing about it is they really are beside each other. But adjacent angles, what does the book say? Share a common what? What does it say? Side and vertex. Share a common side and vertex. So do these share a side or a vertex, the two angles? No, they're just kind of beside each other. So we can't just completely think beside or next to. You kind of think those are next to each other. So the layman's term doesn't really always work. Right here, angle 1 and angle 2 seem to be next to each other, don't they? And they share a side. Well, why is it no? They don't share a vertex. That right there is why it's no. Agreed? Now this, they share a what? Vertex and a what? And that's why it's yes. However, here, why is angle 1 and angle 2 not adjacent? And they're kind of beside each other. They share a common vertex, but they do not share a common what? Side. Easy peasy, right? Huh? Well, we're not talking about bisecting them yet. When you bisect an angle, yes, those two angles will create two adjacent angles. No. Because that's I guess a theorem that when you bisect it you create two adjacent angles, but that's just what happens because they share a side and a vertex. Does that make sense when you draw that line? But to be adjacent, they share the same vertex and common side. You're on the right track. Now, let's talk about this word. Guys, you will use this over and over and over. Over and over, over and over again. Look at the first words. Now, everybody just look up here, please. Do not draw what I'm getting ready to draw. I'll show you how I see a linear pair in my mind. If I was to push these two together and combine them, right? What would happen? What would they create? A straight line right here. That looked to be about the same. It would become that, would it not? Does that make sense? And I guess if I show these in two separate colors, you kind of see that when you combine these two become one, and what happens? In a linear pair, they create a straight what? That is what a linear pair is. Anytime two angles, you push them together, and what happens? They create a what? Straight line. It's a linear pair. Why would these two not be a linear pair? Huh? They don't make, when you push them together, do they make a straight line? It's crooked, isn't it? And here's the other nice thing about a linear pair. How far around have I gone? Kind of a half circle. What's half of a circle? A linear pair will always be two angles that add to 180 degrees. So I could say that the measure of angle 1 plus the measure of angle 2 would equal what? 180 degrees. The two smaller parts equal to what? The whole thing. A lot of times in geometry, you're not going to be able to look at a picture and be able to say, and don't draw this. Everybody look up here. What kind of angle does it look like I drew there? Right angle? But really, if you look at it even closer, it looks like it might be about 88 degrees, doesn't it? Just because it looks like it's what? A right angle. Can I assume it's a right angle? Could be 90.5 degrees, couldn't it? What do they have to put? These have to tell me it's 90 degrees or put what on it? That tells me it's what? What do you think I tried to make those two angles look like they are? What I'm trying to maybe say that they're what? Congruent? Like if this was 60, you might assume by the looks of it that this one's also what? But what if this one's 59 and this one's 60? Do you think you could really tell the difference by looking? Probably not. The only way you can know for sure that these two are congruent is if I mark them congruent, or if it's given to you in the problem. However, what's great about linear pairs, and the point I'm getting to, if you're saying, well, you're going to make a point, is that any time, in any way, I have two angles, no matter how I draw it, what do you think those two angles add to? Why? Because together they made a what? I drew two completely different angles. What do you think those two angles add to? Right? What do you think angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 is going to be? Why? Everybody sit up. Wake up. Because it creates a what? All of these added together have to be what? This is one of those things you can look at a picture and say that that's true. Now, does that make sense? Do you guys see what I'm saying here? Okay? So what's going to happen lots of times? Well, they're going to have a problem like this, and they might even complete it like this. And say that this is x plus 4 and this one is 2x minus 5. X is equal to what? How can I find that? Anybody know? What do I know that, what do I know that these two have to add to? So how can I relate these two? Whatever this thing is plus what? Whatever that thing is has to equal what? So what would my equation be? X plus 4, because that's what that one is, right? Plus 2x minus 5 would have to equal what? Add 1. 3x is equal to 181. Obviously, that's not going to come out even because I just made that up at the top of my head, but it's 60.3 repeating. It's not so hard, is it? You see the point I'm making? If they make a straight line, they add to what? What do these two add to? What about these two? What about these two? Not too bad, huh? That is what this section is based on. Now let's get that those problems out, because we are recording this, so you can watch this, and now you can follow along with this. Okay. It's out there, adjacent, linear pair, and neither. Are these adjacent? Are they a linear pair? Then they are. Are these adjacent? Are they beside each other? Do they share a common vertex? But why did some of you say no? It wasn't that you didn't acknowledge that, but what's the first thing that jumped into your mind, which I almost hope it is? You saw what? Linear pair. So you're not really wrong there. It's just that they're adjacent, and it's a what? A linear pair have to be adjacent angles. Think about it. They got to be beside each other, right? So that's why it's adjacent. So it's an adjacent linear pair. But you weren't wrong to think that. It's adjacent. They're adjacent angles, and they're a what? Linear pair. Are these beside each other? So if they're not adjacent, can they be a linear pair? Thank you. Together, do these two angles create to make a straight line? No, together they create a what? An X. So what's the answer here? That is the worst N ever. Neither. What about here? Are these adjacent? What about here? Are these adjacent? They do share a vertex and a side, but are they a linear pair? Huh? Is this a straight line? That's crooked, right? So no. Here, are they adjacent? Yes, they do share a what? Vertex and side. Do they happily create a straight line together? So they are a linear pair. Because we're just talking about angle 1 and angle 2. You see what I mean? They share a vertex, but they're not beside each other. So a linear pair is what? Two angles that together make a what? Straight angle. What do they need to make the straight line? They need this other angle right here that we don't know the name of. Right? This angle and angle 1 are a linear pair, right? You see what I mean? But these two together, if you erase the middle part out of your mind, they don't create a straight line together. They don't. Angle 1 plus angle 2 does not add to 180. It's a good question. Let's see, in the figure at the right, GB and GF are opposite rays, and GA and GD are opposite rays. What that means is that they create a linear pair, a straight line. Which angle forms a linear pair with AGC? So you got A to G to C. What creates a linear pair with that one? C what? C, you guys see that? So angle CGD. Would you have been right to say DGC? Yeah, you would have. Everybody see that? Number 8, do angle FGE and angle EGC form a linear pair? Angle FGE and angle EGC, do they form a linear pair? Together, these two angles right here highlighted, do they create a straight line? And what's tough is, hey, if you have to, use your fingers or something and erase everything. If you're not a visual person who, I'm able in my mind, to kind of erase that from my mind and just see the two they're talking about. Hey, but if you have problems with that, there's nothing wrong with going the conventional, goofy way that I'm doing right now. Agreed? I mean, is there anything wrong with that? Except that you might kind of look weird if somebody walked up and said, what in the world are you doing? Right? But other than that, does that kind of help me see that those two together don't make a straight line, do they? Okay? I know some people are more visual or spatial than others, and that's not your fault if you're not. Well then, hey, we all got to learn to play hard with what we got. So if we're not good at that, there's ways you can, like that right there. Look at that. I just see those, don't I? There's ways you can help yourself. Agreed? So the answer, no. Name two angles that are adjacent angles. Wow, are there a lot of angles that share a vertex inside here? So is there going to be a lot of right answers here? Absolutely. AGB, BGC, they're adjacent, aren't they? Excuse me, sorry.
If we put no, do we have to justify the answer?
Justify your answer. Well, let's see. GC and GF, GC and GF are not opposite rays. Or together the two angles do not create a straight line. You could say that too. How about that? As long as you know, you can explain why. You don't have the perfect geometry way. Make sense? You guys think you got this? Can we get started?